thank you very much, and appreciate the time to talk to you all of you today. And I'm going to be kicking off a presentation talking about Flash and OpenStack and the impact of cloud computing in the enterprise. So why is there so much excitement about cloud computing in the market today? Fundamentally, I think it's because we're now 10 years into this virtualization revolution in the data center, and the impact of virtualization has been tremendous in the efficiencies that it's brought to infrastructure utilization. The ability to share infrastructure across a wide range of workloads has led to a dramatically more efficient data center from a hardware perspective. But when you look at an operational perspective and how applications and data centers are managed, virtualization really hasn't brought that much change. And as these environments scale up to larger and larger scale, the management constraints of virtualized environments become a real problem. And so something really has to change as these environments get larger and larger. And that's where cloud computing comes into the picture. Cloud computing is this idea that it's no longer about virtual machines. It's about a higher layer of abstraction and automation. It's about managing resource utilization, creating utility consumption models, and making applications portable, as opposed to managing individual virtual machines just like they were a hardware device. So OpenStack is a platform that many of you may have heard of that essentially functions as an operating system for the cloud. This is a project that's about 3 years old now. It was an open source effort that originally came out of Rackspace and NASA, designed to allow large enterprises and service providers to manage their infrastructure through software rather than through traditional virtual machine type interfaces. The project as a whole is a huge collaboration in the industry today. It is probably the largest and fastest growing open source project in the market today. The amount of participation that is seen across the entire spectrum of the computing ecosystem, from software vendors to hardware vendors to networking and storage, is absolutely tremendous. Really, everybody in the industry is working towards making OpenStack a successful model for open source collaboration, as well as building a platform that everybody in the industry can participate in and plug in when it comes to building a cloud computing ecosystem. So what is OpenStack? Fundamentally, what is at the core of it? OpenStack presents an abstracted model for managing underlying virtual and physical resources. It hides a lot of the complexity of the underlying hardware and virtual machine and storage and networking, and presents it out through a common, easy-to-consume API interface. So now you can program your infrastructure like software rather than managing it like hardware. In addition to the API, there's a very simple, easy-to-use self-service model that presents UI and web-based constructs for managing the infrastructure, something that can be presented all the way out potentially to end users. So the model that Amazon pioneered with Amazon Web Services can now be available either through a service provider or through an enterprise data center, all the way directly to the developers and end users of that infrastructure. It provides a lot of the kind of heavy lifting regarding resource management, resource pooling, and it's been designed to scale. It's been designed to run in some of the largest computing environments in the world so that customers can start with a small installation and grow over time without having to constantly replumb their infrastructure. So this is a project that SolidFire has been involved in for about 2.5 years now in various forms. And in particular, SolidFire pioneered and was heavily involved in the block storage effort in OpenStack, which is OpenStack Cinder. And this is a project to allow virtual machine images, applications, and databases to have easy to provision, scalable, and reliable storage in the project. And this is something we've collaborated on with many, many other both storage companies as well as other technology companies participating in the OpenStack project. So that's a little bit about OpenStack. I'd like to talk a little bit about storage and Flash as it relates to OpenStack and as it relates to cloud computing. And there's fundamentally a problem that SolidFire is trying to address here. And that is that OpenStack is a great platform, but traditional enterprise storage really doesn't work at cloud scale. And OpenStack on its own can't really fix that. And this is something I experienced firsthand at my last employer at Rackspace as we were building the Rackspace cloud. The cost, complexity, and management difficulties of traditional enterprise storage make it extremely difficult to deploy in a large-scale cloud environment. And that's really the problem that SolidFire was created to address. For those that aren't familiar with SolidFire, we've built a scale-out all-solid-state storage system designed specifically for large-scale clouds and next-generation data centers. It's the largest, fastest all-solid-state system available on the market today. It utilizes a scale-out model that allows you to start from a few dozen terabytes and scale up to multiple petabytes of capacity and millions of IOPS of performance, but do so very, very efficiently at a very low cost per gigabyte and very high density in terms of cost and power efficiency, which is extremely important for these cloud environments. The fundamental problem that SolidFire was designed to address was this difficult choice you have in the traditional enterprise data center. The choice between deploying applications on dedicated storage environments that lead to very consistent and high levels of performance, but very high operational cost and low utilization rates, or what has become the more common model, which is using a shared infrastructure model through virtualization or cloud computing, where many different applications share the same pool of storage resources. But you end up in an environment where you get very good capacity utilization. However, the cost model can be constrained by challenges related to performance, noisy neighbors, and other issues that make it very difficult to manage the storage in that environment. Fundamentally, in the next generation data center, the data center that OpenStack was created around, we believe that you need a shared unified architecture for all of the applications, but you need the ability to control and provision storage in a very fine-grained manner depending on the requirements for each of those applications. And that's really the environment that SolidFire was created for. There's a number of innovations we've delivered in the platform that are really designed to help enable storage in this next generation data center. And things that are very unique, not just in the flash space, but in the storage market in general. SolidFire is designed around a scale-out model. That's extremely important for enterprise data centers because, for cloud-based data centers, because you don't want to have to be deploying new storage systems every day or every week as these environments scale. A scale-out model that allows you to incrementally and linearly scale capacity and performance is essential to allowing these environments to grow very seamlessly and transparently to the underlying applications. High availability, and not just in from the perspective of data protection, but from the perspective of complete application transparency when failures occur. The ability to maintain consistent, reliable performance in addition to the availability of the data. Guaranteed performance. This is really an area that SolidFire focuses on that's very unique in the flash space. A lot of people in the flash space will talk about the amazing performance that flash offers. SolidFire is focused not just on the raw performance of flash, but the ability to guarantee that performance to thousands of applications at the same time and provision the exact amount of performance that each application needs, rather than simply having a big pool of performance and ending up with a very crowded, noisy scenario where every application is grabbing for performance and nothing can be guaranteed. The use of efficiency technologies is key to making flash affordable and cost-effective at large scale, and we use compression, deduplication, and thin provisioning across this entire scale-out architecture to do that. And then the management automation piece, and this is really where we tie in very tightly to frameworks like OpenStack to allow the provisioning and management of flash to be done not as a standalone kind of storage management task, but as part of the overall cloud infrastructure, as part of the overall provisioning and deployment of applications, rather than down at the virtual machine level. So these are some of the innovations that we've delivered to market. And next up, I'm going to bring Rourke Hilleman up from eBay to talk about eBay's use of OpenStack and Flash. Thank you very much.
Hi, so my name is Rourke Hilleman. I have one of the funnest jobs I've had in a long time, which is basically I'm a technologist at eBay looking at storage coming from 6 months out to about 2 to 3 years out, and then planning a storage strategy for eBay to adopt moving forward. Most people think of eBay in the past as a company that did auctions. Today, auctions is probably less than 30% of our entire site operations. eBay is made up of literally 40 plus adjacencies, and we're acquiring more companies on an annual basis. We've had at least 8 acquisitions in the last 2 years. So eBay Marketplace is one of the largest e-commerce marketplace, but we don't compete with our customers. We actually facilitate commerce between individuals, companies, between various entities. eBay Enterprises is actually a acquisition we just did last year, which is actually more of a fulfillment, where they do things for Toys R Us, Bed Bath & Beyond, where they do the actual inventory, the web, and a lot of fulfillment capabilities. And PayPal's our financial arm, where we've actually started doing things, becoming more closely aligned to being a bank. Now, what eBay is in a transition today to go from e-commerce to actually become a commerce facilitator. Some of the things that we've done is, one of the promotions we're doing is eBay Now, where we're not just offering same-day delivery. In certain select cities in the US and in Europe, we're actually offering the ability, using mobile devices, to have a person buy a product and within an hour or two have it delivered to your location. Not to a fixed location or an address, but to your actual mobile location. So if you're at a concert and you need to get an SD card for your camera, or let's say you forgot to get a ring for your wife for whatever reason and you're at the dinner, you know, you could order it and before the end of dinner it will arrive and you're now safe. So in this aspect, you know, there's a lot of challenges that eBay has. One of the challenges that we're really looking at is how do you facilitate this whole commerce environment? And part of the challenges of that is as eBay goes out and acquires company, we've found that our data centers with our great efficiencies with power, we just announced Quicksilver, which is our basically data center that's off the grid. We have fuel cells. It's all completely off the grid. We provide energy for our own data centers. And we don't put data centers in logical places like you know, cold places. We like to stick them in deserts. So when we start doing things of that nature, you know, how do we take these acquisitions and move them into our data centers? So a lot of these acquisitions and a lot of people we talk to in the industry have the same problems we have. The state of the infrastructure today is pretty much islands of responsibility. You've got business units that own gear. You've got you know, a team that does storage, a team that does networking, does applications, and all these different things. All the automations are usually within that vertical. When you acquire a new company, you're going to have a team that may have did a great job automating networking, but they never touch storage. So storage is still handcrafted. You're looking at compute maybe being fully virtualized, but there's no tie-in between the compute and your storage or your networking. And a lot of the problems that you see today is related to, you know, understanding the traffic access path of your data from ingest all the way down to the storage and back up. And where's that storage? Is it local to the compute? Is it shared? You know, there is no standard today on how people do things. It's when you acquire a new company, they could have done, you know, MongoDB on local disk, or they have MongoDB on shared storage, or who knows what they've done. So looking at the infrastructure as we acquire them, you know, we have to find a way to normalize them so that we can take the efficiency and cost savings of eBay and apply it to these acquisitions. Then we look at Flash. Flash is an interesting animal. It's been around for a long time, but for it to become viable in the industry, it actually had to take 2 steps back and emulate disk. And so Flash as disk, and I love to use that term because it really changes the way you talk to storage array vendors. When they come back and say, oh, we do RAID. I'm like, yeah, so you're using Flash as disk. You're not taking full advantage of Flash. So Flash in its, you know, in its current format is being used in vertical use cases. Usually there's the barrier of price. There's the you know, local use where you put it in your very hot spot. You do things because of the economic impacts, the perceived endurance capability, and just on a as-needed basis. So what happens is when you bring in these companies and they're using Flash locally and they're using, you know, different sets of automation, that company usually lacks a lot of agility. They can't transition from one area to another. There's a long lead time because as you're still handcrafting these servers, you're bringing in things explicit for one use case, but you can't reuse that same gear for a different use case because it wasn't sized properly. And we don't like having to resize things or retrofit things, or when we buy servers, we buy them in tens of thousands, and we want to move them from one use case to another as transparent as possible. And a lot of this is driven by the fact that eBay's operations is really tied to our revenue. If we have an outage of X amount of minutes, we can directly tie that to a monetary value. So we don't ever want to have major amounts of outages where we measure it. We want to be able to withstand failure and still survive. So OpenStack, when we went out and looked at ways of automating, you could talk to VMware, you could talk to all these different companies, HP, Dell. They all have various levels of orchestrations. They can support certain vendors. A lot of them support a large variety. But the problem with them is they're very vertical. There's only a small amount of customer base that they have. What we like about OpenStack is the fact that when it's being developed, it's open to the community, and you now have a large community of people doing development, running them, literally testing at a global scale, and giving feedback to the community on how they're developing OpenStack, where they're seeing benefits, where they're seeing problems, and then having that dialogue. Because eBay, we can't claim we know everything. We know what we know. We're subject matter experts in e-commerce and moving to commerce, but we're not storage array experts. We're not flash experts. But looking at OpenStack and looking at these capabilities, we can now leverage the community. So the promise of OpenStack that we looked at is the large community. Again, virtualization is a checkbox. You have to have that, whether you're VMware, KVM, or whatever. It allows you to create blueprints for orchestrations, to be able to put use cases and repeat them. So if you've rolled up one thing for one person, 10 other groups can take advantage of the exact same thing. Minor changes here, but it's completely available to anybody within our infrastructure. And we don't have to put people, consultants in place. In traditional enterprises, you have what I keep calling a cottage industry. You're sitting there, someone wants a use case with storage and flash, so they come talking to you and they say, size me a server. Okay, let's get a Dell PowerEdge, you do this, you add this storage, and take 20 of those here, 20 of those there. That's painful. That takes a long time. And if you have to support 43 different companies growing every year because your executive staff just likes to buy companies for whatever reason, it becomes a challenge for us. So what we want to do is allow our product development team, basically our customers, to be able to define this themselves and have the agility to move up and down the stack. That's why we're looking at OpenStack, to give us the agility, the scale, and the simplicity of being able to deploy any of these patterns. And it's not just compute and storage. We're looking at it for networking. We're looking at OpenFlow. We're looking at a bunch of variety of different areas, so that when we bring in any type of companies or any type of projects, it's not a problem of defining the SKU. In fact, we're down to literally 3 SKUs. We want to reduce the amount of hardware we have so that we can have greater reusability, greater capabilities of moving use cases around, and that actually helps us in the availability of our environment. But OpenStack, as was stated by my predecessor on the stage, still has problems because as you map it to traditional capabilities, you hit limits. There's only so much an IOPS disk can do. It's great for throughput. It's not really good for IOPS. And as you try to overcommit resources, you're going to hit explicit problems, whether it's memory, whether it's compute. What Flash gives you the ability to do is to get the headroom to overcommit more, because a lot of use cases that virtualize isn't using all the resources. In fact, you may give an application 24 gigabytes and you have 20 of them running on the same machine with only 64 gigs of memory. Well, the only reason that becomes an effective model is because that application may use the entire memory, but may only be spinning in less than 10% of that memory. And so the amount of time it needs to go out of that 10% is small, and the Flash is able to handle the paging and restoring of that memory area at a fast enough rate that you're not seeing any type of impacts at your user level. So the promise of flash gives us the ability of density and the ability to overcommit our virtualized environment to get the cost down significantly lower. When we look at our competitors and like Rackspace or AWS and so on, when we look at our full TCO value, we're actually significantly below a lot of those services with the agility that those services provide to us, we provide to our customer. So the flash, again, everyone keeps thinking high performance, but at dense levels, cost is actually dropping. The asking street price of a TLC flash, which is one of the Samsung's product offering, is down to about 62 cents a gigabyte. And that's actually dropping lower, but a lot of people's afraid that, my God, it doesn't have the endurance to run my workload. The problem in the data centers, most people don't know what their workload read, write, and change rates are. And when you start looking at things like big data or media services, a lot of those are write, create, append, let it sit there. And the change rate is significantly low. That's the reasons in the Flash Memory Summit that happened a couple months ago, Facebook came out and basically said, I want write once flash. Well, I don't want write once flash. I want to be able to write it several times. But the whole message there is, I don't need flash that I can overwrite daily multiple times. I mean, write the whole flash device 3 times in its entire lifetime. And that lifetime, in my view, could easily be 5 to 15 years. So when you converge OpenStack and Flash, what we've seen and what we're expecting as we move forward and mature this is that the infrastructure becomes more agile. You're able to have higher dense application to hypervisor. You get better capability in your I/O throughput. And as you move Flash into a shared storage model, you now have the ability to have the headroom to go wide horizontally across your environment and keep persistence. The biggest area, which I don't know how many people in the infrastructure community is looking at this, the biggest areas we're seeing where Flash could really help us is in a truly elastic data center. When you start looking at moving use cases, especially eBay Sense where we're fully seasonal, we may want to move analytics in the times when we're not high throughput traffic for transactions and use most of our CPUs there. And then you move it to full transactional traffic when Christmas and New Year come around. But you can't do that when you have to pin storage local to a disk. You can't do that if you cannot have the same levels of guarantees, the same resources. If you've scaled individual resources out for a specific use case, you can't move it from one to the other. And the challenge there is in the application that we use for analytics, their model is still locally attached to the compute. But Flash and a lot of our Flash vendors that we're working with today, they're changing that. As the economics of Flash is going down, Hadoop becomes a more interesting play as you put Flash behind it at a much lower cost point than what the Hadoop economy thinks they're getting with disk today. So one of the things that we're looking at is challenging the Flash industry. And this is something I've said in almost every single Flash discussion I've had. We need to move Flash away from being modeled from disk and move it to be modeled as Flash. File systems, up till most recently, it's all been modeled behind a disk. You've got a couple of file systems that have started looking at Flash in more of the larger log file system or things related, but that's still modeling it as Flash as disk, looking at the way disk I/O works. But fundamentally, if you had high density Flash, if you had 8 terabytes of Flash and your over provisioning disappears, in other words, you use it all up after 5 years and you have one more cell failure, that may be a gig, 1 gigabyte or some size cell, your 7.9 terabytes of flash just basically went out the door. It's failed. Why? That's 8 terabytes of flash that you could keep running and have it shrink down to about 500 gigs, and then I make the decision to flip it out and put a new flash device in there. When you start looking at flash with those capabilities, that's completely different than the flash we're getting today. And then you look at the fact that flash today has been deployed as individuals, as singles or mirrored because of the cost. As you see flash shrink in cost, you're now seeing arrays of these large flash devices. And what you really want to do is take the provisioning that's local to them. Local buffering is usually a bad thing. You want to use a global buffer so you can move workload and data. And as you move data on flash, it's better to move the data at a system level than at an individual flash device level. So this is the challenge I'm giving to the flash industry. How do you move us away from a flash as disk and flash as flash? High performance flash is one path everything's headed towards. Again, with all those issues, do we really need high performance flash? Well, yeah, a lot of ticker tape, a lot of vertical stuff requires it, but there's also a lot, 90% of the environment really doesn't need more than 30% of that capability. So one of the things we're looking at is archival flash. How do you take flash, have it last a longer time, 3 drive writes in its entire lifetime, but drop the price so that it's less than a quarter? I think that's going to happen within the next 2 to 3 years before flash is replaced, being replaced by some other type of media. But even those new media will have to have these same challenges addressed, because we have to move away from this whole idea of basically flash as disk.